Now that we understand the business goals and user journeys, we can turn them into an architectural blueprint. In this topic, you'll see how to identify the key services, sketch an initial component diagram, and set up a solid base for deeper technical design. We'll move through this topic in 3 stages. First, you'll firm up the foundations of digital identity and eIDAS. Next, we'll layer on real-world banking context, user journeys, and high-level architecture. Finally, we'll zoom into the technical details behind identity proofing and qualified signatures. In this course, solution architecture is essentially about building a bridge. On one side, you have business goals, regulations, and the user experience you want to deliver. On the other, you have concrete technologies, APIs, and systems that engineers must implement. High-level architecture is the map that connects these sides. It turns messy requirements into clear components, responsibilities, and integrations that all stakeholders can understand and support. For an eIDAS onboarding solution, it helps to see the design in 5 interlocking domains. First, the customer application. This is where the user journey actually happens. Second, identity proofing, confirming who the person really is. Third, the qualified e-signature provider, creating legally valid signatures. Fourth, document management, preparing, storing, and retrieving contracts and evidence. Fifth, the bank's back office, core systems that open accounts and keep records. We'll keep coming back to these domains throughout the course. The customer-facing application is where the whole eIDAS experience becomes real for the user. It guides people through onboarding step by step and explains what information is needed and why. It also shows trust signals, like security badges and clear wording about qualified signatures, while talking to back-end APIs that handle identity proofing and signing behind the scenes. Before a bank can obtain a qualified electronic signature, it needs strong proof of who the customer is. That's where identity proofing and the eIDAS gateway come in. An eIDAS node connects the bank to national eID schemes and returns verified identity attributes, such as name and date of birth, at high assurance, ready to be used for onboarding and signing. A qualified signature service run by a QTSP works like a highly secure signing factory. The document is submitted, the service authenticates the user, and protected cryptographic keys are used to create a qualified electronic signature. The result is a document whose integrity and signer identity are strongly proven and legally recognized across the EU. In our eIDAS use case, think of documents moving through 3 controlled states. First, they are generated by merging a legally approved template with customer data, so every contract is consistent and traceable. Next, the unsigned version is staged, its content is locked, and the system waits for the qualified signature event to attach all evidence. Once signed, the document is archived in a secure versioned vault, keeping both the content and its audit trail verifiable for many years. After identity is verified and the contract is signed, everything has to land in the bank's back office. The CRM holds customer master data and becomes the single source of truth about the person. Core banking is where accounts are created, balances maintained, and products activated. In parallel, the AML engine evaluates the customer and their transactions for financial crime risk. A clean outcome across these systems is what turns a successful onboarding into a live account. In eIDAS architectures, a key decision is where to draw the line between what the bank owns and what it buys. The bank typically keeps customer channels, core banking, and document management in-house on its own infrastructure and operated by internal IT. Identity proofing and qualified signing, however, are usually delegated to specialized providers running as managed SaaS, who assume the trust service regulatory role and associated audits. When you design eIDAS solutions, always distinguish data flows from trust flows. Data flows are the actual payloads, documents, hashes, and identity attributes moving between the bank and the qualified trust service provider. You model these for performance, security, and privacy. Trust flows are legal and cryptographic. The bank's reliance on the QTSP's certificates, policies, and supervision. A useful check is to ask, are we just moving bits or are we delegating legal responsibility? It helps to think in a small set of building blocks. You always start with the user, interacting through some bank system or channel. Anything the bank fully controls is modeled as an internal system. Anything regulated, specialized, or easily replaceable tends to be an external trust service. Between components, you draw data flows, and for anything security relevant, you highlight the trust link that makes those flows both legally and technically reliable. Now let's see how everything comes together in the end-to-end blueprint. The customer only interacts with the bank's front end. That front end orchestrates all the heavy lifting. It drives back office processes, pushes documents into document management, and calls out to external trust services. The identity provider confirms who the user is, and the qualified trust service provider applies the qualified signature. Your architectural responsibility is to keep these integrations clean, secure, and replaceable. Validating an architecture really means asking, does every important requirement have a clear owner? Business objectives like remote onboarding mainly live in the bank's internal systems: product engines, customer portals, and workflows. Regulatory and eIDAS duties lean heavily on QTSP and identity provider services, but evidence still needs to be captured in the bank's records. UX needs are shared. The bank shapes the journey, while external services must integrate smoothly and present trustworthy, understandable flows. You've now seen how to turn a banking onboarding and qualified signature requirement into a structured eIDAS solution. As you move into deeper technical work, keep 3 habits: identify the right components, define clean boundaries, and map end-to-end flows before you dive into detailed design or specific technology choices.